Assalamu alaikum. We're coming back, to the lab. We just would like, to make a kind of a demonstration, to the last two experiments we have. We start, with experiment number 4, which about the parameter which are affecting, the flow of power, whether active or reactive power from both sides, as what we have explained in the slides, I've sent to you. So just simply, for demonstration, in this experiment we are going to use two stations because we want to power supplies. And the first part of it's like kind of scenarios. We want to do different scenarios, and we would like to know, for each scenarios, how's the behavior of the flow of the power. So the first scenario which we are going to conduct is that if we have the sender and receiver voltage are different, but they are in phase, so the phase angle between them is equal 0. So for this one, we want to demonstrate it using two power supplies. So we consider, that this power as a sender and the second power supply as a receiver, and we'll have a transmission line between both of them, and then we want to measure the voltages, sending end voltage, receiving end voltage, and also we want to see in this scenario what's the behavior of the power. So we'll have both watt-var meters in both sides, in the sending inside and the receiver inside. And also we would like to make sure that the phase angle between them is equal 0, as what we can see it here. So we'll start now. What we have, this is the station is set up. So we have, this is a sender portion where we have the power supply, and then what we have here is connected. It's the voltmeter to make sure that the voltage is the same as the other one. Then we have the watt-var meters, and then we have the transmission line. We have the other second watt-var meter, which is for the receiver end, and then we have the second power supply, a second station as the receiver power supply. So first of all, we have to make sure now the angle here, we can see it is equal 0. So we would like to set the voltage equal. So we want to set the same voltage, and we see what will happen to the power supply. So the first one, we will switch on the power supply. It's already switched, for the sending end and for the receiving one, and we'll raise the voltage here to up 180 volts. So we go with 180 volt here. 180 here, we have 180 volt, and we have to do the same for the second one with 180 volt also. So now here we have two voltages are the same and they are in phase. What we notice here that there's no power is flowing. Power here is 0 watt for both of them, 0 watt, 0 watt, and also 0 var for both of them. So which we concluded here, like if we have same voltage and the receiver and the sending on voltage and the angle between them is equal 0, then there will be no power flowing in the system. Now we go to the next step is what we want to raise the voltage in the sending end, and keep the voltage at the receiving end is the same. So we'll raise this one to about 200 volts. So we see with the 200 volts. So now we have the sending end supply is 200 volt, while the receiving end supply is still at 180 volt, and the angle still is 0. So they are in phase. So what we notice here, when and we want to switch on the power, the supply now is to about 60. We have 60 ohm transmission line. So what we notice here, we notice like we have now a var, reactive power, which is about here about 55 or about 60 var. We have very small real power, that's in the sending end, and in the receiving end also we have a small about 5 watt, and we have about also 55 var, which means what now here that whatever power voltage is our active power, reactive power is produced by the supplier, by the sender, is received in the other one, which also means also that the power is flowing from the station number A, which is the sending end station, to station B, which is the receiving end station. So that's the power how it's flow. And it is voltage, the direction is positive, so that means the power is going from the sender to the receiver. Now let's do another scenario where we reduce the voltage from the sending end to 160 volt instead of 180. So we go to 160. and we keep that 180. Now with 160, same what we see how is the power now. Now we have also small real power, which goes to the left, and we have a reactive power, which about maybe 50 also, is going also to the left. And in the other station, we have also reactive power about 50 going to the left, and small real power going to the left. Means what? Means that the power now is changing the direction from the higher voltage, which is 180 volt, to the lower voltage, which is 160 volt. So here's the power is flowing in the opposite direction. So here in this scenario, we conclude what? We conclude that if we have different voltages in the system, and both voltages they are in phase, then the power, reactive power will be flowing from the higher voltage to the lower voltage, and there will be no active power, no real power. Or real power is very small due to the resistivity of the transmission line we have. So that's the first scenario we'll have. We'll prepare for the second scenario and see how it would be going. Thank you. Okay, we're back. The second scenario we are going to demonstrate is that the flow of the real power. Now, flow of real power, as we have it in the second scenario, if we have equal voltages but they are not in phase, then real power would be flow. And to demonstrate that, we introduce here a new instrument to control the or to shift the angle. So we have here the new regulator transformer. This regulating transformer is used just to shift the phase shift, okay, plus and minus 15. So the setup for this experiment is the same thing. So we have two power supplies. Again, one power supply, station A, will representing the sender, the station B will representing the receiver, and then we have transmission lines connecting both of them, and we have both watt meters to measure the active and reactive power, and the phase shift also transformer to shift it. So we'll start with this one. We have like our angle is equal to, so both of them is phase. We switch, and this, by the way, this experiment to make sure that we have same voltage. So we use the fixed terminals 1, 2, 3, 1, 2, 3 in both station. So we switch on the both station here, and then we'll have here both of them on 220 volt. The angle between them is 0, so we can see here that there is no power flow. So we don't have any power flow either from either station. So we'll switch on our transmission line. It's on now. Still the powers, real power is 0, reactive power also is 0. And now we want to see, since we have both voltages 220 volt, we want to change the angle between them and see what happened to the route. So if we go to plus 15 angle, so now here we can see how the power now is changing. So now we have real power here. We have almost 0 reactive power from station number A. Station number 2, we have also real power, which is about 100 watt, and we have small reactive power, about minus 30 var for this one. So here, since here we have what we have plus 15. What we mean by plus 15? This is the angle between E1 and E2. Okay, between E1 and E2, that's is plus 15. So this is so power now. Real power is flowing, which means let us check the second one, which we go to minus 15, and also in the minus 15 we can see also that we have large real power active about 100. We have small reactive power is about also 30 from this station, and from this station also we have 100 real power, and we have a very small reactive power, about 5 var reactive power. And again, this the angle here is minus, so it's leading, and it's lagging, and we can see here always that the power is flowing from the leading part to the lagging bar. So this is the second scenario we have it. Okay, that real power will flow if there is an angle or there's a phase shift between the sender and the receiver end. So that's what is approved. Now in the second or the last scenario we want to check is when we have load. Okay, so when we have a load, we see what happened into this. So I will set up the station, and we'll come back, for the last scenario. Okay, in this last demonstration, we want to show that the real power, or the phase shift angle, it will occur between the sender and receiver ends only if we have real power flowing in the system. If there is no real power flowing in the system, so the phase shift angle between both voltages will be equal 0. And in this experiment, we are going to introduce the loads now. So we have resistive, capacitive, and inductive loads. The type flows which normally will appear. So we'll see here if how it will happen to the phase shift between the voltages in both sides. Okay, so we have here the voltage E1 and E2 which are across the load, and we see if what will happen to the phase shift, if we have both of them. So we'll demonstrate it first with the resistor. So we'll connect our resistor. Say we put about 300 ohm resistor, and we adjust our voltage to 200 volts. So we'll put here E1, which we have here, to about 200 volt. With the 200 volt here, what we can see, and we switch on our transmission line. So what we see here, we see that we have now resistive load. We have real power flowing. Okay, so from this the system to the load, from the power supply to the load. So we have about 100 watt here, and we have also received 100 watt in the second in the load. For the VARs, we have a very little VAR here, reactive power, which here is about maybe 30 something. While here in the load, at the load side, we do have 0 VAR. And that's to prove why, because we are connected only a resistive load. So there is no reactive power will be absorbed by the load. So here we can see we have a phase shift between the voltages, E1 and E2. E1 from the power supply, and E2 across the across the load. So we have a phase shift type. Now what we'll do now, we'll change our load from resistive to inductive and see what will happen. So switch on our transmission line, and we switch to the inductive load. So here we have inductive load also with about 300, and you can see here we don't have any power because there is no voltages coming, and we have the 200 volt from the sending and receiver, and we switch on our transmission line. And what we see here in our transmission line, now we can see that the real power is 0 from the power supply to the transmission or to the load. Also the real power is almost 0 here, but we have a reactive power. So we have here about 90 VAR reactive power. Also here we have received about maybe 80 VAR. Some of them it will be consumed by the transmission line. And for the phase shift, we can see here, notice that the phase shift is equal 0. Our phase shift here is equal 0. Why? As I said, because there is no real power flowing. So that's for the reactive. Let us check for the capacitive loads. Let us switch our one, and we go to the capacitive load. So we have our capacitive load here. We connect it. And again, we want to switch on our transmission line, and we see same thing here. We have what we have reactive power. We have 0 real power from the power supply. 0 watt. We have almost about how much here? About 85 VAR. Here we have also 0 watt, and we have about 100 watt. And we can see here they are negative reactive power. Okay, which means that the power is going from the supply, from the receiver to the system, or to the supply. So here the objective of this demonstration here is to make sure that there will be phase shift only if there is a real power flowing in the system. If there is no real power flowing in the system, so the phase shift angle will be 0, as we can see here, 0 in the reactive power, reactive load, and inductive load, and another 0 also in the capacitive load. So by this we demonstrate the 3 scenarios which we already explained in the theory, where we discussed the parameter which is fitting the flow of the power, reactive and real power, from the power supply to the load, and how they are the power changing either the voltage level on both sides, or the phase shift angle between both of them. I hope you know this small demonstration shed some lights, okay, on the experiment. That's experiment number 4. The next experiment is about how we can increase the flow of power in transmission line, and we'll demonstrate 2 ways, okay, to how to increase the flow of the power. And in the next experiment, inshallah ta'ala, we'll demonstrate. Thank you very much. And if you have any question, don't hesitate, please, to send me an email, or you can write in the blackboard, and I will be happy to answer any question for you. Thank you. See you.